So I'm Allison Mills, I'm a science writer here at Michigan Tech, and today we have Nina Mahmoudian joining us, and she is talking to us about robotics and specifically robotic controls. And so would you mind elaborating just a little on that?
So I'm very interested in groups of robots and how to coordinate them for different missions, different applications, and how to efficiently use them. And then the application can go from underwater to ground for, from disaster relief to biological observation to space exploration. You can imagine the type of applications that we are considering.
Yeah. And so as part of this, I know that your research, it spans so many different aspects of robotic controls. It would be wonderful if you could talk about your National Science Foundation Award, your career award.
So it is a great recognition. It shows the trust that NSF has in me as a researcher and the interest in my research, its potential and its future impact. I take it as a great opportunity for myself and my students to work on a very cool topic for 5 years and then share it with the community.
Awesome. I would love to have you lay out basically the research that you're doing with continuous operation. And so if you wouldn't mind taking us through how this is both a science problem and a technology problem, I would love to hear that.
Yeah, so this is a very interesting problem. The success of a lot of robotic activities and robotic operations lie in it is measured by how long it can last. And then when that is important, then it is very important to consider that we have limited battery life or limited energy resources in our robotic network. Now, for this work, we are really trying to solve this problem from different aspects. We want to coordinate the robots effectively, and then we want to consider recharging as part of robotic operation cycle. And with this, we think that we guarantee the persistence of operation. So now, for that, there are different challenges. There are technological challenges because we need to develop hardware, the efficient hardware. We need to be cost efficient, and we want to really take the human from this cycle out. So those are the challenges that we need to address from the hardware perspective. So we need to guarantee reliability in that aspect. And then from the science, we really need to solve this problem. It is a big optimization problem, it is resource allocation problem, and in top level. And then in the in the second tier of that, it is really a path planning, motion control problem. So we really this is an interdisciplinary research. We understand that this has different aspects, and we think that I think that we are unique in the sense that we are considering these challenges in parallel, and we are considering the environmental constraints, the hardware challenges, and the necessary science to respond to these challenges.
Yeah, and for me, that really summarizes some of the challenges of engineering in general, because it's often hidden. The problems that engineers work on, we kind of don't want to see as the public because, it's part of an infrastructure that is basically hidden to people who aren't engineers.
That's true.
And so what I'm hoping we can do, because not everybody that will be watching this video will understand the intricacies of that infrastructure.
Okay.
So I'm hoping that we can give them something very visual to connect to.
Okay.
So if you wouldn't mind kind of laying out what this would visually look like. That brings us to our metaphor. You have a lovely metaphor for how to coordinate all of these robots. Would you mind laying that out?
Sure. In nature, we see group coordination in flock of birds, army of ants, and a school of fish. For fish, we see them aggregate in structured ways in shapes depending on their type and their activity. In our work, we want group of robots to continuously operate for long-term missions. The robot performance is limited to its battery life. We want to add mobile charger to the operation cycle for guaranteed persistence. So let's break it down. Imagine we have a couple of robots surveying seafloor. Usually, they have to turn around and head back to the ship. But with a little charging robot, they can get their batteries filled and stay out for longer missions. To keep this continuous operation going, the charging robot glides in between working robots, and together they all swim like a school of fish.
If you want more awesome science stories from Michigan Tech, check out Unscripted. That's mtu.edu/unscripted.